welcome to lesson 23.4 in the Python tutorial series. Today we're going to be looking at a new data type that is similar to a list, and that's the data type tuple. A tuple is similar to a list in that it can contain multiple amounts of information, and that information is separated by index locations, or you can access it with index locations. Now, sometimes you'll refer to this hear this referred to as a tuple. I've heard it both ways, and quite honestly, I don't know which one is technically correct. It's really kind of interchangeable, but I refer to it as a tuple. And I hadn't really thought of doing this particular lesson up until, like I said, about 3 days ago, and I realized in seeing some of the example programs that were in the comments that it's something we need to address because it's important, and it's definitely something that's going to come up at the level we're at now. So we're going to compare a tuple to a list in this lesson right here and take a look at some of the differences and what makes the two different data types different from one another. So today we're going to be doing lesson 23.4 on the tuple data type. So here we are. We have our Python shell and our Python window open, and we'll do a little bit of work in the Python shell. And again, the purpose of this video is just to provide an example of the differences between a tuple and a list. I don't think we'll have a challenge program for lesson 23.4. This will be more of an informational type video. So let's just start with a little bit of a example from what we did in the last video. Let's create a list variable. And so I'm going to call my list variable list1. And I'm going to add the values 1, 6, 10, 11, and 20. Now, if you remember some of the list methods or list functions that we looked at in the last video, you can see that we can do the length of list1. That will return how many elements are in it. In this case, there's 5. So 5 individual numbers. We can take a look at the min of list1 and get the value of 1 as the smallest number. We can take the max of list1 and get a 20, and we can look at individual elements using index location. So 0, 1, 2, if I want to access this 10, I can access list number 1 at index location 2 and get a value of 10. So really simply put, that is a list variable, and I can even tell it's a list variable by running the type function on list 1 and see that the object data type is list. So how is this different than a tuple, and what is a tuple? Let's create a variable called tuple1. And in it, I'm going to add the values 1, 6, 10, 11, and 20. The only difference is that instead of using brackets to denote a list, I'm going to use parentheses to denote a tuple. I hit enter. Everything looks okay. If I access the variable tuple1, I can see that all the information that I entered is there. I can take a look at the length of tuple number 1 and get a 5, just like the list. I can take the min of tuple 1 and get the 1. I can take the max and get the 20. So far, almost everything looks the exact same. In fact, if I do a type of tuple1, the only difference I can see so far is this is a tuple data type instead of a list data type. For new programmers, this is why the two can sometimes be hard to sort out. They're behaving almost identical. I can use the same functions, they look the same. If it weren't for the brackets, there wouldn't be a real easy way to tell the difference between these two because they're almost the exact same. If I take tuple number 1 at index location 2, I'm getting the same 10 that I did when I accessed the list at index location 2. So then the question is, what is the difference between these two data types? The big difference has to do with list mutability. If I were to take list number 1, or list 1 as a variable, at index location 2, and change that to, let's say, 15, I don't have any problems with that right there, and when I access list number 1, I can see that the value at index location number 2 has been changed to a 15. When I access the tuple variable at index location 2, I'm going to get an error. It's going to be a type error, and it says tuple object does not support item assignment. That is the huge difference between these two data types. A list is considered to be mutable. That is, I can change the elements of a list. A tuple, by contrast, is an immutable data type. That means you cannot change individual elements of a tuple. Now, the big thing that this ends up being used for are things like coordinates or locations on the screen when we get into graphics. It represents a data type that you don't want to have manipulated, that you don't want to accidentally change. So, really, when you look at the difference between a tuple and a list, what you're looking at is one is mutable, we can change the elements, and one is not, meaning we cannot change the individual elements. Let's head over to our programming window and let's create kind of a simple little program to provide an example of where tuples will most likely encroach on your programs. I'm going to write a program. We'll call this player hit points, and we'll set it equal to 10. The player has 10 hit points, and the player experience points will be set equal to 0. So you can imagine an adventure game where the player starts out with 10 hit points and hasn't earned any experience points yet. Next, I'm going to write a little function for this program that will give the user some hit points. And so we're going to call this function, we're going to define it, and we're going to call it advance. And this will give a random amount of hit points to our player. So let's import random, since we're going to want to generate a random number. And the first thing that's going to happen is we're going to set a variable HP equal to a random number, a random integer, between 1 and 6. Then we're going to return the value of HP when this function is done running. And I'll even put a print statement so we can watch it happen. Let's print the user has gained %s HP and pass in the hit points value, or this local HP variable here, for that statement. So we'll run this program now. And over here in our Python shell, let's run advance. So we can see the user has gained 6 hit points, and this function is returning a value of 6. Perfect. And if we run it again, we should find that we're getting a random number each time. So we got a 5 there, a 1. And so our random function is working more or less okay now. Now, as it stands right now, if I just run advance, this isn't going to do me any good because this return value is just being lost. Certainly it's returning 5, but it's not being stored anywhere. So advance is worth a value of 5, but it's not being stored anywhere. I want the player hit points to be incremented by the number of hit points that the user, or that advance, throws out there. And I can even tell this right now. Before I run this program again, let's take a look at player HP. It's equal to 10, which is the same as this initial value right here. Even though the user gained 5 hit points, I never added it to the player's hit points, so that number just sort of disappeared. But since this entire function is worth a value of 5, I'm incrementing the player's hit points by 5. And when I run this program now, I can see the user's gained 4 hit points. And if I check the player HP variable, it's equal to 14. If I were to run this again, so let's say player HP plus equals advance, the user gained 2 hit points this time, and that was added to my total number of hit points. If I simply run advance, I can see that the user was supposed to gain 4 hit points, and it returned a number of 4, but since I didn't add that value to player hit points, that never occurred, and player hit points remained stagnant. So that's just a little bit of a review. But what a lot of new programmers do is they have their functions calculate multiple values. For example, they might then say experience equals random.randint between 1 and 6 so that the user is gaining experience, and print the user has gained %s experience, and pass in that experience value right there. Well, one thing will happen if I return experience next. And let's go ahead and take this function call out of here for right now. I've got two return statements in this function, which you should know isn't acceptable. This is going to break my function right here, and return exp will never happen. When I run this program, so let's go ahead and run advance, we can see that it did calculate random numbers correctly. The users gained 5 hit points and 3 experience, but the function is only returning a value of 5. It's not returning this experience value. So when programmers run into this, what they like to do, or what newer ones do, is they return 2 values. Okay, then I want you to return hit points and experience points together. And technically, this will work. It is a single return statement, but it's returning 2 bits of information. If I were to execute this program now and run advance, I can see that the return statement actually returned a tuple, a value of 4 and 5 together. But since a tuple is considered a single bit of information, I mean, it has different index locations, Python sees this as returning one value. So when you use a return statement that has multiple variables or multiple bits of information being returned, Python will always return that as a tuple. Now I can access this information simply by saying, let's set a variable equal to advance for right now. So we'll call this variable test, and we'll set it equal to advance. I can see the user gained 6 hit points and 5 experience, and I can access those individual numbers by, say, accessing test at index location 0. That will give me this 6, and test at index location 1 will give me this 5. So I'm able to access multiple bits of information if I know that the return statement returned a tuple of information. But I can't use this outright. I can't simply add hit points to hit points and experience to experience, because if I do that here inside my function, let's say I take player HP and add HP to it, and then take player experience and add experience to it before everything's returned, I'm going to get an error. Because remember, these guys right here are local variables. They're not accessing the same bit of information as these right here, so player hit points does not exist within this function. So when I go to add a number to player hit points, Python is kind of confused. It says you don't have a variable named player hit points, so I don't know what to add to, and your program crashes. So we can get rid of that right there. The best thing to do in this situation would just be to write 2 separate functions and have one function that deals with hit points and another function that deals specifically with experience points. But if you're creative about how you write your programs, you can do something that's not really a good programming habit to get into, but it is something that you're able to do. If I were to run advance, so let's say we'll call this results equals advance. I know that the first bit of this tuple is going to be hit points, and the second bit of this tuple is going to be experience. So I could then theoretically say player hit points gets incremented by results at index location 0, knowing that index location 0 is hit points. And then I could add player experience points at results 1. Running this program, I can see the user has gained 2 hit points and 5 experience points, but this is what's known as unpacking a tuple. I'm unpacking it, so I know that HP and EXP show up at index location 0 and 1, so I'm simply running some code to unpack that and access those bits of information, because they're immutable and I can't change them within the tuple itself. If I access player hit points now, I can see that it did indeed increase by 2, and if I access player experience, that did increase by 5, as the program told me it would. In general, within the world of programming, something like this would be more accepted than global variables within your functions, but it's still a good habit to try and make your functions each deal with one very specific bit of information, but sometimes it's a useful skill to have to know what a tuple is and know how to unpack a tuple from your functions. And then if I added, say, a gold, a bit of information about gold, and I say I'm going to have a variable player gold, and I'm going to start that equal to 0, and this function, although it shouldn't, is going to deal with gold, and we say gold equals random.randint 1 through, or we'll say between 10 and 20 gold. We'll print the user has gained %s gold. We now have a new bit of information that this function would be returning, gold, and gold would be at index location number 2. So if I run this program now, I am getting a random gold amount, and if I set test equal to advance, this test variable will now have 3 bits of information: hit points, experience, and gold. So accessing test, I now have a tuple with 3 bits of information instead of 2 bits of information. Now that I know gold is at index location 2, I can simply increment player gold by the results at index location 2 and make those changes permanent, because now I'm accessing these as global variables as they're not part of my function. And I guess the last side note I would make is, by default, Python will always return multiple bits of information as a tuple, unless you specifically tell Python that you want it returned as a list. The way I can do that is by simply putting these guys in brackets and letting Python know that I want to return a list of hit points, experience, and gold. When I do that, I can see that 3, 4, and 16 were my values. It's stored in this variable results. And now, when I check results, I'm getting the list 3, 4, and 16, and not the tuple of 3, 4, or 16. Now, just like I did up here with our test variable, if I say test equals advance, I get some new numbers, but now my test is a list variable, making it mutable, instead of a tuple. So you can return a list, but if you don't specifically tell Python that you want to return a list, you're going to get a tuple, and that's how you, and this right here is how you can deal with it in your program. So that's going to do it for lesson 23.4. There is no challenge program. Like I said, that was purely for information. It's something that I do oftentimes get questions on, and as we get into more advanced data types, I think it's important to know what a tuple is and where they come from and how you can work with them. So that we won't really spend any more time on them unless they come up in the programs we're using, but hopefully you got something out of that particular lesson. As always, if you have any questions, if there's anything that I can help you with, you're having trouble with your programs that you're writing, leave them in the comments and I'll be happy to help you debug them and get them working. So as always, thank you so much for watching the Python tutorial series, and have a great day.